Example 3. Determine the zeros of g of x and use them to factor g as a product of linear factors. And then we'll verify with a graphing app and sketch the graph. Okay? So first of all, this is degree 3. So we have 3 total complex zeros. We need to maybe figure out if we have any rational zeros. So let's look at our p's and q's. So p is all the factors of the constant. So we're going to have plus or minus 1, 3, and 9. And q's are all possible factors of the leading coefficient, which is just 1. So we only have plus or minus 1 here. So all of our p's over q's could possibly be 1 over 1, which is 1, 3 over 1, which is 3, or 9 over 1, which is 9. These are our possible rational zeros. Now, from the graph in Desmos, we're going to see that we have an x-intercept. So let's go over to Desmos right now, and we'll type this in. I didn't mean to pull that up. I meant to go to Chrome. So as I type this in, you'll see how Desmos graphs everything you're doing in real time. So I'm going to just type in x cubed, which you do x with the caret key above the 6 on my computer, and then plus 3x squared plus 3x plus 9. So we may need to zoom out here or zoom in. Let's see, what do I mean? I'm going to get this in a little bit so we can kind of see the whole graph a little bit better. So this does look like a cubic S curve, and I can see that it has a y-intercept of 9. That's our constant of 9. And it also looks like we might have a real zero at -3. So I'm confirming with just this graphing utility that I see one real zero at -3. So we'll sketch that on our paper when I get back to it in a moment. So the one real zero I saw from Desmos was -3. That was our one x-intercept. So we can confirm that that's a zero by evaluating g at -3. So that's going to be -3 cubed plus 3 times -3 squared plus 3 times -3 plus 9. Well, 3 times -3 is -9 plus 9. Those are exact opposites. This is -27 plus 3 times +9, which is +27. So yes, that is definitely our zero. So let's use synthetic division and reduce this g of x to a quadratic. So the leading coefficient is 1. Then I have 3 as the coefficient of the x squared, 3 is the coefficient of x to the first degree, and my constant of 9. So just really quickly, 1 times -3 is -3, then I get a zero sum, 0, 3 plus 0 is 3, and then I get -9. I already knew this was a 0. So my depressed quadratic polynomial is x squared plus 3. I can set this equal to 0, and I can solve for x. So when I take the square root of both sides, I see I'm going to have x is equal to plus or minus the square root of -3, which we know that's going to be plus or minus I root 3. So those are our two imaginary zeros. So I think we have everything because we have positive I root 3, negative I root 3, and we have -3. And those are the 3 zeros that we have. So remember what that graph looked like. Let's see, 1, 2, -3 was here, and up at 9, let's say we had this S curve kind of like that, and we can go back and look at Desmos, but it looks something like that. So our zeros are the real 0 of negative 3, and then two imaginary zeros, I root 3 and negative I root 3. And as a product of linear factors, we have x minus a negative 3 simplifies to x plus 3. We have x minus I root 3, and then x minus a negative I root 3 simplifies to x plus I root 3.